Now that we know how to capture an optical image, we want to convert this optical image into a digital image so that we can provide it to a computer vision system for further analysis. So in this lecture, we're going to start with a brief history of imaging. We look at the major inventions that led to the camera as it stands today, and we'll argue that perhaps the most important invention that's taken place in the history of imaging is that of the image sensor. And in particular, we're going to look at two types of image sensors, CCD sensors and CMOS sensors, and we look at how they work. It really is a remarkable piece of technology. And then we look at the characteristics of image sensors, in particular resolution, which is the number of pixels you end up with in an image, noise, what are the different sources of noise, undesirable effects that you end up with in images, and then dynamic range, which is a range of brightness values that an image sensor is able to measure. And next, we'll talk about color. Color is a really fascinating topic. It turns out that color is really human response to wavelength. So we look at how image sensors can be designed to capture color. And next, we're going to look at the camera response function. So if you have a point in the scene of a certain brightness and it produces a brightness in the image, if you increase the brightness of the point in the scene, you can expect that its image brightness is also going to increase, but not necessarily linearly. It could be a non-linear mapping between scene brightness and image brightness, and that's defined by the response function. So we look at the camera response function and how we can find the response function given any camera. And then we'll talk about the popular topic of HDR, or high dynamic range imaging. How can one use an image sensor with limited dynamic range to capture images with wider dynamic range? And finally, we'll look at some of nature's image sensors. We'll look at some very interesting techniques that nature has evolved in terms of scanning images. And finally, we'll talk about the retina of the human eye.